Purna Devi from KSET. Are you able to unmute?
Good evening, sir.
Good evening. Okay. Are you able to unmute, right?
Sir, hello.
Yeah, that other team members are joining.
Yeah, yes, sir. They are on the way.
Okay. Sneha and Shanmugha Priya.
Yes, sir.
Just check with your ma'am. She's joining. At what time she will be joining? Dr. Malati.
At 4:30, sir.
Ask her to join.
I'll intimate, sir.
Yeah, 10 minutes before because.
Okay, sir.
Good evening, Anu ma'am.
Good evening. Snega was there as an MC earlier, la?
I think, yeah, she's from VCW.
VCW, yeah,
Both.
And
Shanmugha
Shanmugha
Priya
Priya
also.
is from the career guidance thing.
Yeah,
She's in Varadu's group, I think.
Correct. I put the message to Mr. Sudarsan. I sent a Zoom detail also already through WhatsApp. Already Arun they were sent through mail.
Yeah, he should have sent, yeah.
Yeah, I sent through WhatsApp also. He said, sure, I'll join before 10 minutes.
Okay.
From this.
So who else we know in this group? Mohana Priya is faculty, right?
Yeah, faculty, EC member.
Yeah, she has also joined.
Yeah, the principal and the chairperson, that senior people, they have done a vaccine today. So that's they were not able to join because of that. Yeah.
Actually, they have taken the survey for next year.
I
and
think.
The survey they have taken.
Yeah, he has taken it. Dr. Malati is joining. So for inaugural address.
Who else is there in this group from the career guidance thing? Can you chat? Shanmugha Priya?
Yes, ma'am. I was the one, ma'am.
Yeah, you are the one. And who else from your college is there?
Those are not in this session, ma'am.
Divanetra or something, right?
But she's not joining today, ma'am.
Today, okay.
Diventra. Nice.
Diventra, yeah. Different name.
Good evening, Mr. Arun Dev.
Hey, hi, Robin.
Hey, good evening, Arun.
No.
I just put a message reminder to Mr. Sudarsan. Said
you will join. Your injection, I think vaccination, all okay?
I think so. ஒரு மாதிரி மந்தமா இருக்கு.
Okay.
Over மந்தமா இருக்கு.
Okay.
Let's see.
Anu ma'am, all are in recording in YouTube because YouTube is started.
Oh. So, okay, sorry. You didn't tell me that.
Okay. Nice.
Sorry.
A lot of people from VCW senior management have gone for vaccination, Arun.
Oh,
They've
okay.
also gone for
So
vaccine.
that's the reason principal is not joining. Instead of EC member, Dr. Malathi is joining.
Okay.
Shanmugha Priya and Sneha,
Yes, sir.
that madam is joining.
Yes, sir. I have pinged her, sir.
Okay, okay.
Shall I call her and intimate, sir?
Yeah, please.
Okay, sir.
Because exactly 4:30 will start.
Okay, sir. I'll inform her.
Good evening, Dr. Malathi.
Sir, good evening, sir.
Arun Dev, Mr. Arun Dev is there.
Hey, good evening, madam. Thanks for joining.
Sir, good evening, sir. This is Malathi from Vivekananda College of Engineering for Women.
Good evening, Malti
Yeah, ma'am. Good evening, ma'am.
and Mohana Priya.
Mohanapriya. Dr. Mohanapriya, you can talk. I have made you co-host. Good evening, Mr. Sudarshan. Good evening, sir. You can able to unmute. That's some other Sudarshan.
Student, I think.
Student, yeah, NEC. I request the participants to change their display name as given in the format. I have put it in the chat box. Malathi ma'am,
Yeah, sir.
students are joining from your college. other students?
So students are joining now.
Yeah. Ask them to join it.
Yeah, sir. Yeah, sir. I'll ask them to join soon.
Thank you, ma'am. Yes. Good evening, Mr. Sudarshan.
Good evening.
Yeah, good evening. I will stop sharing my screen. You can share your screen also.
Sure.
Shall I do it, sir?
Yeah, go ahead, please.
Mr. Arun Dev and Anuradha Ramanujam is there.
Hello.
Hey,
Yeah, good evening, sir.
good evening, sir.
Good evening. Just give me 1 minute. I'm going to share my screen.
So good evening, Sudarshan, sir.
Good evening.
Yeah, sir.
Hello.
Hi, sir.
Where are you based, Mr. Sudarshan? Bangalore or
No, Chennai, sir.
very much in Chennai? Okay.
No plans of moving elsewhere.
Yeah, a lot can be done here. So,
Yeah. You speak Tamil, sir?
sorry,
You speak Tamil?
I speak Tamil.
Yes.
Yes. Yeah, Arun Dev is a little misleading.
என்ன இல்லை இந்த திருநாட்டில் எதற்கு கையேந்த வேண்டும் வெளிநாட்டில்.
Very good, sir.
You see my screen, sir?
Yes, sir.
Yeah, we can see your screen.
Okay, great.
So the format we have today is we have a brief address by the senior staff from one of the institutes who's a host college for today.
Mhm.
And then you have your presentation and your talk,
Sure.
followed by 3 student teams for the 3 topics that you have given. Now, following that, you give your comments about their presentation and any takeaways, and then we conclude. So that's the format that we have followed.
Okay, how much time do I get for the talk, sir?
Entirely up to you. Anywhere between 45 minutes and 1 hour, you can choose.
That is too short.
Sorry?
That is too short.
I didn't get you.
I said it is too short.
I agree. I mean, in most of these subjects, that's one of the challenges that we have.
I will try. I will try to with
Fine,
1
fine.
hour.
Be flexible.
இவரு பிரின்சிபல் ஜாயின் பண்ணலான்னு சொல்லிட்டாராம் பிரியாட்ட. டீன் சார்ட்ட மட்டும் சார் மேம் லிங்க் அனுப்பியிருக்காங்க, முடிஞ்சா ஜாயின் பண்ணிடுங்க அப்படின்னு சொல்லி நானே பேசிக்கிறேன். அவங்க யாரையும் நான் எழுதலையம்மா. நம்ம எதுனாலும் நாளைக்கு பேசிக்கலாமா? நாளைக்கு பேசிக்கலாம்.
Robin, can you start?
Now time is 4:30. Yes.
Yes, go ahead.
Good evening to all. I am Robin, PALS Program Management Office. Campus event, Aqua session, hosted by Vivekananda College of Engineering for Women. I would request the MC of the day, D. Shanmugapriya and BM Sneha, to take care of the proceedings. Thank you. Shanmugapriya and Sneha.
Yes, sir. Am I audible?
Yes.
Yes. Good evening, all. I am Shanmugapriya and I am going to be the host of this session. And here are some instructions that you should follow. First of all should be muted until the session ends. The next thing is your attendance should be in the chat box in the format of a short name of your college, hyphen your name, hyphen your role, that is your student or faculty. And if you have any doubts or questions, you put it in the chat box. It will be clarified in the end of the session by our PALS team. And Yeah, these are all the instructions, and this is the time for a quick intro about PALS, and that will be given by Mr. Arun Dev, sir, PALS champion. Over to you, sir.
Yeah, good evening. Thank you. Good evening, everyone. Thank you for joining for this session. Today's session is an acquire session, which by its very nature is focused on new topics on what we generally call as exponential technologies, such as artificial intelligence, sensors, 3D printing, blockchain. Over the course of the last 8 months, you would have had quite a few of these sessions from us. I recollect 2 artificial intelligence sessions, one on healthcare, the other one is about NGOs. And more recently, we had a session on blockchain and its applications, and also a session by IBM expanding on that further. So today's session is continuing in the same vein. It's also in the field of health. We have Mr. Sudarshan Santhiappan, Chief Scientific Officer of Buddy Health, who will be talking to us about the subject. I now hand it back to the MC to take it forward. Thank you.
Yes, sir. Thank you so much. And now I invite Dr. L. Malati ma'am, Head of the Department of Computer Science and Engineering and PALS Executive Member in Vivekananda College of Engineering for Women, to share her views about PALS. Over to you, ma'am.
Good evening to everyone. Thank you, Shanmugha Priya, for inviting me. So on behalf of Vivekananda College of Engineering for Women, I wholeheartedly welcome today's guest, Mr. Sudarshan Santhiappan, Chief Scientist and co-founder of Buddy Health, and the PALS core team members for this campus event Acquire. So I also extend my welcome to all the participants from other colleges and participants from our own college. I welcome you all for this wonderful event. So we have a quote like, every thought we produce, everything we say, every action we do, it becomes our signature. As like this quote, the specialty of PALS team is that identifying the right people for the right place. So like that, the PALS team identified Mr. Sudarshan Santhiappan sir for this program. So specialist in artificial intelligence and medical language processing, that's natural language processing for medical healthcare records. So our college, Vivekananda College of Engineering for Women, is part of Vivekananda Educational Institution, which is started with the motto of empowering women students, especially from rural environment. So the organization like PALS will support us to empower our students in various aspects, starting from students' basic skill development, personality development, and subject skills and other deep skills. So the PALS, we are a member of, for the PALS for the past 5 years. So initially we started with a few students as a team in that. So later for the last 2 years, motivated the students and especially the girl students. And now all the PALS programs are organized by directly our students. They are motivated, they improve their confidence, and they are good in organizing these kind of events. So PALS team help us to do those empowerment. So the program, this Acquire program is like developing deep skills with the specific subject. The programs like this will help the students to improve their knowledge and deep skills in the particular subject. So I thank the PALS team for making this program, these kind of events with each college. Thank you.
Thanks a lot, ma'am. And it's time to read the chief guest profile. It will be read by Sneha from VCEW. We welcome you, Sneha.
Thank you, Shanmugapriya. Excellence is not being the best, but it's doing your best. We are pleased to welcome the eminent chief guest, keynote speaker, Mr. Sudarshan Santhiappan sir, Chief Scientist and co-founder, Buddy Health. Mr. Sudarshan Santhiappan sir, born in Kadalur and brought up in Chennai, he completed his bachelor's degree in electronics instrumentation with University Gold Medal from the Madras University. He did his master's in computer engineering from IIT Madras. He also completed his PhD in computer engineering from IIT Madras. He is an incisive leader with over 20 years of invaluable experience in leading artificial intelligence research and development projects for an end-to-end artificially intelligent product development lifecycle. He is highly capable of acting as an owner of multiple products and giving expert opinions to the organization or clients with respect to the competition. And he is a facilitation manager and a research scientist with rich and extensive experience in predictive modeling, informed decision making, and big data analytics using statistical machine learning, soft computing methods, and knowledge bases. He is a skilled communicator with honed leadership, team building, and mentoring capabilities. He is a strong believer of measure, analyze, and control strategy for solving problems and sustaining consistent performance improvement. Currently, he's hiring researchers for Buddy Research and Development. And we are delighted to welcome you for this PAL Secure meeting, sir. Thank you.
Thank you.
Thanks a lot for waiting us, sir. And we wholeheartedly invite you to share your experience with us, sir.
Yeah, sure. At the end, I will do that. Should I just start?
Yes, sir, please go ahead.
Okay. Yeah, sorry.
Yeah.
I was waiting for a cue. Sorry.
Please go ahead.
Okay. So good evening, everybody. I don't see any of your faces, so please make some noise so that I know that I'm speaking to some human beings other than speaking to a screen. Okay, so today's topic is to share some of the experiences that I've been having with healthcare data, especially the application of AI and natural language processing for solving different healthcare use cases. So that would be the coverage for today's talk. So the way I want to keep it is I'll be dabbling about a lot of things, but more than that, I want to show some demonstration of some of the technology that we have built at Buddy.ai. So that would help you get a grip on how AI can solve some very interesting problems in interesting ways or through interesting ways. So there is one correction on the modus operandi, which is the MC said everyone should only communicate through the chat box. I am not a big fan of that. So if you have a question, please stop me anytime and shoot your question. I'll be very glad to answer. This will also ensure that I'm having a dialogue with a bunch of human beings. So keeping it with the chat box, you know, I get a feeling of speaking to IVRs or bots. So we have not reached that point yet. Singularity will take another decade to come, and let us continue to be humans until machines can take over all of us. So please, let's talk. No chatting, please. Okay. So Buddy MLP. So Buddy is a wordplay of the term Buddhi. So our CEO came up with this nice variation of Buddhi, and we founded this company as Buddy Health. Right now, we call ourselves as Buddy.ai to generalize it for multiple verticals other than healthcare also. But our primary focus is on healthcare as of today. But we will be diversifying to other verticals in the near future. So we rechristened our company as Buddy.ai, and we prefer being called that way. Buddy Health is still a valid name. It's still a legal name, but we are in the process of transitioning from Buddy Health to Buddy.ai. So what is this company? So we are into healthcare. So back in 2013, when we founded this company, we wanted to try 4 different verticals when we founded this company in 2013. So one of it was healthcare. The others were multimedia, e-commerce, and fintech, other than the healthcare. And within a few months, we figured out that there is a whole lot of problems in healthcare which will expect us to provide undivided attention. So we dropped off all the other verticals and clinged on to the healthcare vertical only. So far we have been playing in the healthcare space. And why we chose healthcare? Because 8 years back, the infusion of artificial intelligence into healthcare was not really heard of for various practical reasons. Of course, in the last 1 or 2 decades, AI has taken a lot of uprising. A lot of good things are happening, also bad things. What I mean by bad thing is abuse of AI, right? Unfair use of AI. That's what I mean by bad thing. So in a lot of situations, we seem to observe that AI is being abused or not fairly used for solving problems. So that is something I'm really worried of. Anyways, so healthcare is a space where AI penetration was not really much 7-8 years back, and we saw a lot of problems which sounded solvable through AI. So that's why we started to develop this company from scratch and fix the vertical as healthcare. And right now we are one of the front runners in AI for healthcare. Today there are a lot of companies dabbling about applications of AI in healthcare, but we have this early start advantage. And we have done so much research and we have developed so many products, which is clearly giving us some advantage over other competitors who have come up in the recent times. So one of our core areas, our core strength is medical language processing, which is how you apply natural language processing and artificial intelligence to understand medical texts. So the medical text that I'm meaning is the electronic health record. So in the Indian context, we call it as a medical chart or a report. We call that as a medical report. So at the end of a hospital visit, we typically get a medical report from the hospital as a printed matter, which is rarely understood. But we still get this 1-page or 4-page document when we exit an hospital after an inpatient stay for a day or 2, whatever. So this medical report talks about what happened to the patient, why the patient got admitted, what was the treatment given to the patient. So it's complete documentation of the stay. So if somebody got admitted to the hospital, let's say after a fall or after a fracture, and if they had to get admitted on the same day, and if they had to undergo a minor surgery for correcting the fracture, and let's say after 2 days, when they are released from the hospital gives a report which summarizes from the time of admission to the time of relief, what has happened to the patient and what is the post-care. I mean, what should be done as the continuity of care. So all these things will be put in a piece of paper and we get that as the discharge report or discharge summary. So this is the data that we consume in Buddy.ai. And for now, all the medical charts that we have been processing are coming from the US. And we hope in the near to far future time frame, we will start applying our technologies for Indian medical charts and Indian medical system also. But that is work in progress. There are a lot of practical reasons why we are not doing it in India. Number one, India does not want to pay. So India operates on a freemium model. So most of anything that is popular, most likely it was given for free initially. So that's called a freemium model. So you get customer base by giving it for free. And then once the customer base is dependent on you, you start charging them. So that's called the freemium model. Jio adapted that model. They gave the phone service for free for more than a year, and now they are charging for the phone use. And that model works. In India, freemium only works. Premium never works in India. But the kind of services that we provide, the kind of tools that we have built at Buddy.ai, we have spent a lot of money to build that. So the Indian price structure would not work as of today, but sooner we will make it available for large masses. So we have the Saravana Stores model also, right, in business. So you don't have to make a thicker margin, you can make a slimmer margin, but you compensate for that by scaling up your sale. So Saravana Stores model is that. So their margins are smaller, but they do bulk sale to get the overall profit. So that is a model that will also work in India. So we are preparing ourselves to get into that route, and sooner in a year or two time frame, we will start playing in Indian healthcare systems also. But for now, it's only the US. So that is how we have positioned ourselves. And the way as I said previously, our core competency is on application of AI and natural language processing to understand medical texts. And why should we understand medical texts? That is the next question we'll have to answer. The reason is there is a lot of information which is available on these charts. And if you look at it holistically, let's say if you have access to lots of medical charts which are being created at a hospital, larger intelligence can be captured from that in order to design new applications, or in order to get very interesting insights and so on and so forth. So there are advantages for the hospital, there are advantages for the patient, there are advantages for the administrative side of the state. So in all these three areas, there are a lot of advantages once we start understanding the medical charts or the EHRs constructed or created at every point of care. Right now, the knowledge is siloed. The patients don't understand it at all. The hospitals and the doctors are the only stakeholders who can understand the medical text. But information which is present there in those EHRs, if the understanding is opened up, a lot of new things can be created. A lot of very interesting use cases might come up. For example, let's say if you have a pharma, if there is a pharma company, a pharmaceutical company, they are very interested in understanding the drug interaction with the patient. So for example, if you go to a nearby clinic and you talk to the doctor, when he prescribes a new medicine to you, the doctor will ask you to come back and give a feedback on the medicine. I'm sure you would have encountered this problem multiple times in your lives, as and when you visit a local physician, and when the physician prescribes a new medicine from his point of view to you, which you would not know that you are being prescribed a new medicine because you don't know what that is. Honestly, we are all ignorant people. And this doctor will ask you to call him or message him or come back to the clinic after a couple of days if the fever got subsided or if the pain got subsided. So basically, he's trying the experiment. He's trying the new medicine on you. He's doing a drug trial without even taking our consent. So because Indian healthcare is so disorganized or unorganized, a lot of things are done in an ad hoc style, which are unheard of in the Western nations. A physician cannot do this experiment in the US. That person will lose his license, or someone practicing in Europe cannot do this exercise. They will also lose their license. But in India, there is no regulation around it. In fact, the doctors don't even give you bills, right? For whatever money they take from you, they don't even give you bills. Nothing goes on record. So it is because the healthcare system in India is so unorganized. And I'm only waiting for the government to step in and organize or enforce organization in healthcare systems. Then automation and AI applications will start blooming. Until then, it's not happening. So India will continue to be what it is today. So these are reasons why we did not penetrate, or we did not try even to attempt the Indian region for trying our products. Okay, so that's the pretext of what the company is and what we do in general. And today I'm going to talk about some of the applications of AI towards understanding natural language or understanding the medical language, right? So we are going to describe the problem, and we are going to see some solutions to that, which we have tried in our company. I'm going to demonstrate those solutions to you, and that's about it. And I'll try to finish it as early as possible. I'm not sure. So the thing is, as I said before, electronic health record is a documentation which people other than doctors or people other than practicing medical fellows, nobody else can understand them. But there is a lot of information, there is wealth of information present in those charts, with which we can do wonders. We can do systemic changes, we can do a lot of efficiency correction. A lot of things are possible, but understanding them is kind of very hard. So what we try to do is we try to teach machines to understand the medical text. And the way we teach the machines is by leveraging the deep learning black magic, because many people think deep learning is black magic or AI itself is black magic. But as a practicing researcher, I won't accept that that claim. It might appear like black magic if you see it from the outside. The moment you start engaging yourself with the core technology and the science of it, it is basically math. And if you want to call math as black magic, fine. You can call deep learning also as black magic. But generally put, all the problems that we solve using deep learning are all mathematically sound problems or mathematically sound solutions. So there is no black magic in deep learning or in AI. But you know, from the customer's point of view, humans really get excited when they cannot understand how things are happening, right? So people get really excited when you have you know, turns and curves in a path. They really get excited. People like uncertainty. So that's the fun part of it. But healthcare system works in a completely different direction. So in healthcare systems, if we say we want to do AI, and when we make a prediction or when we provide a solution without explanation, nobody is going to accept that. Especially in clinical decision support systems, which are used a lot in modern day healthcare practices. So if a particular recommendation is given by a system based on statistics, based on data, whatever, and if the recommendation is coming out without explanation, nobody is going to trust that, even if the recommendation is correct. So healthcare system demands explainability, demands traceability. So there are additional demands in the application of AI towards healthcare. And these demands do not exist in a lot of other places. For example, in e-commerce, nobody cares why you are getting a recommendation. As long as you like the recommendation, good. We don't want to really understand why this thing is recommended to us. On the contrary, let's say in a newspaper website, if a particular article is shown on the front page, you're not going to really question why that article is coming in the front page. Right? As long as the article is interesting for you to read, you're just going to accept it, accept clicking that link and going to start read that, right? So you don't really need explanation for why something is happening in a lot of verticals, but in healthcare vertical, explanation is crucial. Without explanation, nobody is going to even listen to you. When you go to somebody with an AI product or an AI idea, if you cannot explain why you could do this, nobody's going to even listen to you. So that is an additional, very strict constraint in the healthcare vertical, right? So moving on. So there are a lot of problems that we solve as a part of the healthcare analytics. The first problem we solve is called auto coding. So for example, when you go to a hospital and if you are an insurance patient, and the money is paid by the insurance company on your behalf, you don't have to pay for the service that the hospital has provided you. So the moment you exited the facility after the medical service, the hospital will undergo a detailed process with the insurance company to get the money back, right? And when they do that, they send the whole lot of documentation which was created during your stay at the hospital to the insurance company, and the insurance company will have to read it, understand it, find problems in it, and then based on whatever they understood, they will approve or reject or partially approve the claimed amount. So it's a very complex routine. So someone says they will pay on behalf of a patient. The hospital provides care to the patient. Now the hospital goes to this third party asking money, and the third party will challenge the hospital on different grounds. They will try to find fault, right? Their objective is to minimize the payout, and the hospital's objective is to maximize the pay-in, right? It's a zero-sum game. So there cannot be a situation where both the hospital and the insurance company can win. It's only one party wins, the other party loses. It's called the zero-sum game, right? So in order to execute this process, it takes roughly 3 to 6 months in India. In the US, it takes about 1 to 3 months for getting the money back, depending upon how nice the documentation was and how smooth the process went. And when everything is sent as text files, in India, it is happening that way. Everything is sent as text files, and the insurance people, they will also have doctors on their side. They will read the insurance documents manually, understand what is there in the documentation, and based on that, they make the claim adjustment or whatever. And since there is a lot of humans in the loop, it is taking a lot of time. That's why in India, it takes about 3 to 6 months for getting the payment settled. In the US, they went one step ahead. They tried to automate the text reading process. So they came up with this idea called codification. So instead of reading a long text, you translate the text into a bunch of codes. So there are 2 popular codes. One is called the diagnosis code, which is called ICD. And the other one is called the procedure code, which is called CPT. So in a medical chart, only these 2 matters will be there. So it talks about what are the problems that the patient is suffering from and for which the hospital has offered the services. So those will all be covered in diagnosis codes. And what are the services that the hospital gave the patient, and those services, aka procedures, will all be covered by CPT codes. So instead of reading a whole document, if you look at the ICD codes and CPT codes, you will understand the glimpse or understand the outline of what is done, why the patient came to the hospital and what was the service given to the patient. All those things can be quickly analyzed if things are codified. And this coding process is a manual process. So, but who does it? Nobody in the US does it because they are too expensive. So they offload it to countries like India, where there is a battalion of human coders who will read the documentation and assign proper codes to it. So ultimately, the US side benefits because they are spending less time in reading the document. But India is doing the same process, or India-like countries, India, Philippines, a lot of countries who does it, Brazil and all, they do this kind of work. And those people take a small portion of money to read the document and code the document. So as the first line of product, we built autocoders, which are machines that can read the document and assign proper codes to it. So that is the auto coding problem. I'm going to show a demonstration of that. And so there are a lot of other things also. So the general idea is we want to understand the EHR to speed up a lot of processes that happen behind the scene between hospitals and insurance companies. And that process chain is called RCM. It stands for Revenue Cycle Management, RCM. And Buddy started in 2013 with a single motto that we want to automate RCM end to end. So we are still automating it, and we have not finished automating the entire pipeline because it's a really huge problem. And we have probably covered 70% of the pipeline, and some more work is yet to be done. And some of the other interesting problems that we try to solve are clinical decision support. Decision support is, if a patient is coming with a prehistory and today that patient has a different condition, as a doctor, I have to ask the patient about the history. So let's say if somebody is coming to a doctor with fever, and this person is already a high BP and sugar patient. right? The first question the doctor asks the patient usually is, are there comorbid conditions? Are they suffering from any other conditions for which they take regular medication? Like these are questions that they have to ask before even start triaging their current condition, right? So what we say is, as a part of clinical decision support system, we compile the history of the patient and give bullet points for the doctor to quickly glimpse on it and avoid asking that question to the patient. That way the engagement time can be reduced, right? So in India, if you look at it, a doctor, see the ratio between doctors and patient is pathetic. Like it's 1:5,000 or 1:10,000, or maybe 1:a few thousands. That is a ratio in India. In the US, I think it is little better, but it is still bad. So the case is, how much time do a doctor get to spend with the patient? That time is very small. And within that time, if you have to do a lot of background study, the quality of care will go down. So what we say is, we will do the heavy lifting, we'll do the donkey work, let the machines do the donkey work and curate the data for you and give you bullet pointers. So you don't have to ask this question to the patient. Maybe spend more time in asking questions about the current problem, engage with the patient, show empathy to the patient. So the point of care can be improved to provide good quality of care, right? So CDS allows physicians to spend quality time with patients instead of doing rhetorical work. So that is CDS, right? Clinical decision support systems. There are other things. For example, let's say if you are looking at a patient and we want to find similar patients for which some services have been done before. For example, let's say in a hospital which might have seen several thousands of patients. Let's say today the hospital is receiving a patient with a unique problem, and if the hospital immediately can get curious about, okay, have we seen problems like this in the past, and what is the kind of service given to that patient for solving this problem? So imagine you have a search engine where I can submit the current patient's quick notes. We call it the physician notes. Let's say I submit a physician notes, and the system goes and searches the corpus of all the medical charts which were created previously and finds relevant medical charts and presents it to you in a rank order. So the problem in hand, which is today's problem from a new patient, is no longer an unknown problem, because similar problems have been already dealt in the past, and any person in the emergency room can handle it if the additional information is made available. Today, emergency room requires experienced staff to take corrective actions quickly. And if they cannot take corrective actions, they immediately make a call to a senior doctor, no matter what time it is. And they take the advice from the senior doctor and then take a corrective action. This is how things happen in emergency room today in India. But imagine we have a search engine where you can search for the past patients with similar conditions, and that will give you some bullet points ahead of time before you even call the senior doctor. So a senior doctor, the time you take to call the senior doctor to get some corrective actions or recommendations from the senior doctor, instead of asking the senior doctor a blank question, if you go to the senior doctor with some pre-existing notes, then the communication can be much more efficient. So a search engine is a very interesting proposition here, which will help a doctor, let's say a junior doctor, to get exposure to cases similar to what they are encountering on the day. So this is possible only if we can make machines understand EHRs. And we have a solution for that also, right? Moving on. So how we solve the MLP problem, right? So if you look at an EHR, it is a free running text, right? Like a comprehension, like a composition, a multi-page document, and it's a free running text. So it may have sections, section headers and all, and different sections may talk about different aspects of the patient, but it is a free running text. So we have to study the document step by step to understand what is there in the document, right? And the way we do that is by using standard natural language processing tools. there are ready-made natural language processing tools which will allow us to identify sections, which will allow us to identify important entities in the document. We call it data elements, important data elements from the document. And we can also apply the same natural language processing algorithms to identify the relationship between a pair of data elements that we call the relationship extraction. So we can extract data elements from the document, and we can translate these data elements into clinical concepts. So there are standardized clinical concepts available and made public to the open community, so that you can build systems with those standardized clinical concepts. So the starting point is extract data elements from the charts, and then the next thing is transform the data element into a standardized clinical concept, and then try to draw lines between a pair of clinical concepts. So which means ultimately from a medical charts, we will end up constructing a graph, or we can construct a graph. So Buddy.ai is our stronghold is how we convert a medical chart into a knowledge graph. So once the unstructured information gets translated into a structured information as a graph, then a lot of ready-made algorithms can work. A lot of ready-made graph algorithms can work on it. So what we are doing is we are transforming a problem from being unknown to a problem which is already solved. So we are transforming the problem from one space to another space. And once a problem comes to the solvable problems domain, then standard algorithms are available which can be applied to solve a lot of downstream applications, which can be applied to build a lot of downstream applications. So that is a strategy we always take. How do you transform the unknown problem to a known problem? This is where we apply a lot of deep learning tech, AI, knowledge systems, and stuff like that. So generally put, we have a clinical chart which is incoming, which is the incoming document, and also an unstructured document. And BuddyMLP aims at extracting the clinical information, which we call the data elements, and then map these clinical data elements into clinical concepts, which is based on a standard. The standard we use is called SNOMED, SNOMED. It's a standard ontology which is available for the public, published by CMS. And you can use SNOMED ontology to map the data elements that we cover, that we extract in an EHR, into a concept ID. They call it CID, concept ID, right? Once the information goes from the the practical language to standardized language, then it makes the solutions elegant, because the number of unknowns on the standardized variation or the standardized representation are lower compared to the non-standard version of the clinical text. See, every doctor have their own style of documenting the same matter, right? So Dr. A can write the story in one style, Dr. B can write the same story in a different style, depending upon what they are used to. But as a machine, we'll have to see both of them semantically, right? So if both the doctors are talking about the same meaning, then the interpretation of the chart should be the same, no matter the syntactic variations are there, no matter even if the syntactic variations are there, right? So we are more interested in the concepts, more interested in the semantics of the concepts rather than the syntax variations, which will be the reality, because different individuals create the documentation in different styles. So the way we do that is by applying multiple processes. So we start with OCR, because the majority of the charts which are available from hospitals are printed and scanned documents. I don't know why they do that. They print it and then they take a copy, they take a photocopy of it and store it as images. Some hospitals are still in the age-old time, right? So the way they do digitization is by physically taking photocopies of the medical charts. That is how they maintain digitization. But ideally, it should be constructed as a Word document or a PDF, and the PDF itself can be stored. But many EMRs still operate with a decade-old logic, and they are still using printing and scanning approach. But I hope these things will change in the near future, I think the documentation will all be clean, no more OCRs. But till the transition is complete, we will have the OCR always in the pipeline. And OCR also means that the quality of the document can be a problem, because when you print and when you scan the printed document, the quality of the scanner is going to have a big effect on the content which are recoverable from the text. If the fax machine or if the OCR, if the scan machine had some problems, then the output images will have a lot of noise. And when the image contains a lot of noise, then OCR systems will have a difficult time extracting text from it. So these are some of the practical problems because of today's legacy systems. But hopefully in the future, the legacy systems are gone and we will get the clean digital copies like Word documents or PDFs or any standard document formats. And once the documents are extracted, the documents contain two different varieties or two different modalities of information. One is plain text information, which is free running text. And the other thing is structured information, which is usually presented as a table. So when tables are present in a document, the way you read it is very different from the way you read free text. So you need to have a separate toolkit for understanding tables, detecting the tables and understanding the tables from the medical chart. So for that, we have developed a technology called Dexter. We call it Dexter. We call the particular application as Dexter. Okay, and then once the information is all collected after OCRing and after Dextering, these are not English words, I'm just making it up, sorry. Once the information is all collected, then we have to do a veracity check. So veracity means how good the quality of text is. And if there are spelling problems, if there are truncations in text, and if there are some damages in the text, and we try to use some corrective measures like spelling correction, grammar correction, and all those stuff. Of course, these are based on English language models, and we apply these techniques to do a little bit of error correction. There is no guarantee that we can correct all the errors, but some errors can be definitely corrected. And that fixes the veracity of the document. So usually documents that come through the OCR route, the quality will not be great. So it may be 90% or 85%, sometimes as worse as 50% quality. But if something is a printed material, right? Let's see, if something is a PDF or if something is a Word document, information extraction or a table extraction will work much better compared to working on top of scanned images which are OCR'd by a OCR suite. Moving on. So after the text is prepared, we have a cascaded system which will do different aspects. Again, I'm going to show these as demo. The first one is shallow parsing, which basically identifies different sections in the document. So the sections are usually identified by a section header, and the text between consecutive section headers can be the body of a section. That's a heuristic. Sometimes these heuristics might not work, and we have corrective measures for fixing the problems with heuristics also. So we have a shallow parser which will identify different sections in a medical chart. Once the sections are identified, then it goes to a deep parser where it identifies the various data elements which are present in a document. And then once the data elements are all processed, then we standardize it using the SNOMED-like ontologies to assign specific concept IDs for every data element captured. So there are some interesting variations during data elements capture. So let's say if the document says the patient reported no fever, right? So if you look at data elements, fever is a data element, but the message that is delivered is the patient is not suffering from fever because the patient reported no fever. So we have to handle negation appropriately. So sometimes good findings or a normal behavior is documented in the medical chart. So they say there is no inflammation, and this particular image looks clean, or whatever, the temperature looks normal. So people have their own creative ways of documenting good findings or normal findings, versus people have their own creative ways of representing problems. I mean, if something is an anomaly or if something is deviating from normalcy, they will document it appropriately. So they will say chest X-ray is clean, there is no no inflammation found on the kidney, something like that. So when some information is presented like that, if information is presented like that, we will have to understand it, or we'll have to try understanding it semantically instead of looking at keywords only features. See, what I'm trying to tell you is this is not a simple keyword lookup. So that's what I'm trying to tell you. So the shallow parser or the deep parser is not a simple keywords lookup based extracting information. So when I mean data element extraction from the deparsed text, so the data elements are captured and understood in context with the neighboring sentences and keywords around the particular captured keyword. Because the meaning of a particular word greatly varies depending upon which context this particular word is appearing. Right? Let's say the patient suffers from cold. Right? The word cold means probably congestion, something to do with breathing, right? And there may be another place where the patient has cold feet, right? So if somebody's foot is too cold, so that creates some problems. So there, that cold has a different meaning, right? The cold is really modifying something else, right? So in the first instance, cold itself is a condition. In the second instance, cold is not a condition. Cold is modifying a condition. So usually the foot needs to be warm, reasonably warm. But if somebody has a cold foot or cold feet, that can lead to other issues. That is that the cold feet could be due to different reasons. I'm not trying to get into the reasons, but I'm just illustrating it with that example. So the meaning of the word cold is polysemic, right? It has multiple meanings depending upon the context in which the word is appearing. So a simple keyword lookup based parser will not work. So we have a deep learning parser using LSTM-CRF models, and that is a sequence engine. That's a sequence classification model. And this sequence classification model tries to understand the meaning of a particular keyword based on the context in which that keyword is appearing. So it is not a simple keyword lookup. So we'll have to remember that. So instead of doing this, I'm just going to pause now and want to show you a quick demo of the information extraction. So give me 1 minute. Do you have any questions?
Sir, if they have any questions, they would put it in the chat box, sir, and at the end of the section, you could clarify them, sir.
But I said otherwise, right? I said it differently. Yeah, she wants me to talk to a bot. Okay. Do you see my screen?
Yes, sir, it is visible.
Yes, sir.
Yes, sir.
Good. So look at this example. So I have put an EHR on the left-hand side. So this is an electronic health record. Some of the information might be masked to protect the identity of the patient, but just look at the general flow of it, right? So there are different sections like allergy, current medication, medication administration summary, prescription. So these are some of the sections we see here. So there's this chief complaint section. There is this history. All these are history, medical history, social history, psychiatric history, and all these things. So a chart may have a lot of information, but usually a chart is a free running text. So if you see from the top to bottom, this is a free running text. So what I'm doing is we are trying to understand how this information can get converted to different aspects. So in one of the slides, I said we first start with section parsing or the shallow parsing. So this is the output of shallow parser. So it is trying to capture different sections. I mean, these boxes represent different sections. And all these are automatically identified. I will change this text so that you will understand what I mean. So I'm just scrolling through it slowly. So it is identifying this larger unit as the medication section. And then this is the discharge data section, assessment plan section. And this is the nursing notes area. There's a physical exam section, chief complaint section. All these are different sections. And once these sections are identified, then we get into the deparsing routine, where we identify also the different data elements which are present in the document. So for example, so this chief complaint section, the body ache is the condition, and there is also vomiting this patient is suffering from, and that's a sign and symptom. And so look at this. It says no psych. So the negation is nicely captured so that this particular thing will be understood in context of the negation. And so look at this. There is this drug, ketorolac, I cannot pronounce it, sorry. And this itself is identified as a drug, and the strength of the medicine is captured, and the route or the mode is mentioned. And so you understand the idea, right? So I'm going to change to a different document. So that you will understand that I'm not really faking it. So this is a different report. Okay. So this is the report, and there is a chief complaint section, history of present illness, allergies, home medications, and miscellaneous medication, review of systems. These are sections, right? Labs and diagnostic, hematology. These are all different sections which are found in this chart. This is an emergency room chart. So somebody has come to the emergency room for some problem. What is the problem? Patient seen and examined. Okay, I think there is this breathing problem, bronchitis. I think this problem, yeah, I think the patient had acute bronchitis, which is difficulty in breathing, and the patient also suffers from nausea and vomiting. It is something to do with breathing trouble, probably an elderly patient. I don't know if the age is visible. No, it is not an elderly patient. Okay. Okay, so let's look at the parsed output. So the chief complaint is captured, HPA section, the history of present illness is captured, allergies captured, medication captured, review of systems captured, physical exam captured, diagnostic data captured, lab captured, and this is medication captured, impressions captured. So these sections are nicely captured initially. And once the sections are captured, we go to the deparsed output, and where we see coughing, myalgia, so I don't know what that means. Okay, running nose, and she denies diarrhea. Look at this. So diarrhea is a condition which is a different condition, but this patient says this patient does not have diarrhea. So denies is negating this diarrhea, right? So we are capturing that nicely so that we will not assign diarrhea as a known condition for this patient. And likewise, dysuria, you know what that means. And this person has a history of chronic chest pain. So we'll have to, this is the history. So if someone is already suffering from chest pain, and when they go to a doctor, they'll have to say that they have a history of chest pain. Based on that, the diagnosis will completely change. So we need to understand the history of the patient before even starting a conversation. So look at this, aspirin is the drug, the strength is there, the tablet form, and the tablet has to be chewed, and it has to be every day you have to take it. Likewise, another calcium tablet, 40 mg and daily, and then pioglitazone, I don't know what that is. So another 30 mg tablet, whatever. So the thing is, the model is able to find out find out what each keyword or each phrase means, and the labeling of that phrase is in context with what is there in the neighborhood, right? Depending upon where the particular phrase is occurring, the meaning of it might change, because that's how the documents are usually written, right? So this is the nicely parsed output. And I told you about medical coding, right? So look at this. This is when I inputted this chart, it has already identified the different codes. These are CPT codes, and this is a level 4 code. So it is kind of an urgent care. And there are these different procedures which are done on the patient, which is 99053. And the hospital level, it is top level, which is 285, which is really very emergent case. I think this patient might have come in a very bad shape. So that's why they are given the highest level code. 285 is the highest level code. 284 is one step down. And these are the different procedures done and whatnot. So this is assigning these kind of codes is what I called as medical coding. And right now these codes are assigned automatically by a machine. And the machine understands these texts from this chart, and based on whatever it has read in the chart, it is assigning these codes automatically. So this is one very big problem we solve as a company. And this problem is critical to solve because it allows different hospitals to scale up faster. Because right now they wait too much time. They wait for too much time to get the money back. So with automation like this, the cycle time can reduce significantly. So the quality of care can improve because they will have more money in the pot to offer quality of care. Right now, a lot of things operate on credit, even in the US hospitals. Right? Okay. Sorry with my cam. Okay, I'm going to go back to the slideshow. So moving on. So the way we do that is by following different steps. I'm going to skip over that. So some of the steps are tokenization, part of speech tagging, named entity recognition, negation handling, modifiers, and all those stuff. So we identify different different types of information present in the chart depending upon where they occur. So the example you see on the screen talks about different keywords that are found in the chart, and based on that we can take decisions. So the yellow color text is all condition, the orange color one is symptom, blue is negation, and green is findings. So these are different types of information which are extracted during the deparsing stage. And when we extract this information, we'll have to transform the information into standard texts using concept normalization. So there might be different concepts. For example, this light-headed might have a different concept, and and this okay, he felt like he was not able to process images correctly. So this is something to do with vision. Could be a vision problem, or it could be due to a vision problem due to headaches. So the information that is found here will have to be read properly in context of this negation, and appropriately translated into a particular clinical concept, which is a standardized form of information representation. Because the text here are all mostly written in local language, depending upon what language the physician speaks. So these need not be standard language or standardized language. So we'll have to understand the local language of this physician, and based on whatever that we capture, we'll have to standardize them using appropriate standardized dictionaries and ontologies. That's what we do. Especially in drugs, this will be a big problem. And there is another ontology called RxNorm, RxNorm, RxNorm. RxNorm allows you to standardize drug names into proper canonical names, and it will also tell you a generic name. For example, Let's say if you buy Crocin from market, right, or if you buy a Dolo 650, right, both are paracetamol, right? Paracetamol is the generic name. So there could be 100 different variations of paracetamol in the market, and different tablets may be priced differently, but ultimately their formula is the same. So whether you have a shot of Crocin or whether you have a shot of paracetamol 650, the end effect is going to be pain killing, right? The pain, whatever pain you have, it could be body pain or muscle pain or headache or fever. It will all be subsided when you take paracetamol as an inside medicine. And this paracetamol can come in the name of Crocin. It can also come in the name of Dolo. Both have the same effect, right? So the generic name is paracetamol, the brand name is Crocin and Dolo, right? Those things have to be normalized, because when people write documentation, they may say, I prescribe Crocin tablets for the pain relief, and that actually means paracetamol. I mean, another doctor may say Dolo 650 was recommended for the pain relief. Both of it, although syntactically different, they mean the same thing. So this is why we need the normalization to be worked upon. Moving on. So let me see how many more slides I have. Okay, so I'm going to stop here with this presentation. I'm going to change my presentation. Just give me 1 minute. So there is a very interesting use case we encountered some time back, where we were given a medical text in all caps. So the chart that we saw, the medical charts that we receive, we were given documents in free text form, but the text was totally capitalized. So usually when you are presented with a text which is capitalized, it is extremely hard for you to read it. It would be extremely hard for you to read it, right? And a lot of syntactic cues will be gone. For example, if you say COPD, COPD is a medical condition, chronic obstructive pulmonary disease. If COPD is written in all caps, it means something. But if COPD is written in lowercase, it will be seen as a spelling mistake. I mean, it might have been read as cold, COLD, where P is mistyped as L, right? So the meaning completely changes when the information is presented to us without the case, the uppercase, lowercase, the first letter cap, and all those information. So this was a very recent problem which we encountered, and we wanted to translate this problem. We wanted to solve this problem, and so we built a quick model. We just spent one weekend. No, sorry, not even a weekend. We just spent one evening to get to the solution using deep learning tech. And I just want to show a demonstration of that solution. Just give me 1 minute. So this is an example of, this is a demo page we have to show a sample. So what I'm going to do is I'm going to take a piece of text. So this is the original piece of text, right? And I'm going to convert that to all caps. Just give me 1 minute. So what I'm going to do is I'm going to change the case of it. Let me see if I have a text already. instead of this text, let me give this text. So instead of all caps, let us try the other way. I mean, the entire text is lowercase. Both are problematic, right? Because we need this variation in the text to study and understand what are they really trying to communicate. So what I'm doing is I'm passing an all small text as an input, and I'm going to give it to this model and see what comes out of that. So this is some junk here. I'm going to remove it. Process again. Okay. So just read yourself. Try to read this yourself. Do you find this is easy to read or this is easy to read? I'm sure this is easy to read because this is the natural way that we are already used to in reading the text. So what we are trying to say here is, irrespective of whatever be the case of the input, the cases are corrected automatically by the model, by a deep learning model, which is again an LSTM-CRF model, a sequence classifier. And we just built a model in one evening, and we were able to get to the solution really fast. So the point is, although the sequence labeling model is meant for a different objective, we just translated the problem to a sequence classification problem, and we were able to solve it in one evening. So that is what I'm trying to communicate here. So this was a client specific problem. So when a client was giving data to us, they usually give the data in the normal casing, but I don't know what happened. Some mess up the database administrator might have done. So all the data that we received were all received in all caps. So this is the ulta of that. This is all small, and we received the data in all caps, and that made it impossible for us to read the text. And so we had to do something to get the shape properly. And what we did is something very trivial. So we have a lot of text available with us. And what we did is we uppercased all the text, and we created a parallel corpus, normal cased text and the equivalent uppercase text. We created a parallel corpus. And then we learned a mapping between the words coming on the normal cased to the words that are coming on the uppercase. We just learned a mapping. So no matter whatever be the input case, depending upon the sequence of characters and the context in which the sequence of characters are going to appear, the case of that particular token will be decided. So that is how we model this problem. And what you see on the screen is the outcome of that particular model, right? And this is one interesting demo I wanted to see. Want you all to see. The next demo I want you to see is another interesting one. Just give me 1 minute.
Sorry to interrupt, sir.
Yeah.
We have 7 more minutes.
I told you, right? This is too short.
Thank you.
Yeah. Okay. So this is the table extraction demo. So I said, right, when information is presented in a table, how do you extract everything from it? So I'm going to show some example. Let's try this. So this is a piece of text that we received. This is from a medical chart, and it has a nice table here. And let's see if you are able to extract this table accurately using some AI. So the AI that we used here is a mixture of image processing AI and language processing AI. So there are models which are used to identify the table borders. So look at this. This is identified as a table, the green box, and the other, this is also identified as a table. So this is basically a 2-column table, right? This is a 2-column several rows table. This is also a 2-column several rows table. And this is a 4-row and 5-column table. And all these 3 tables are nicely identified. And look at the last table. So the header is nicely caught. All the three texts are also appropriately caught. So this is a homegrown module that we built, and this is a combination of several pre-existing models and the power of transfer learning. So transfer learning is a very interesting idea. So the thing is, let's say you build a model for a particular task, and you have a similar task but not the same task, and you want to rebuild the model for the new task, which is relatively similar to the original task. So what we think, what we can do is we can borrow the knowledge that has been learned in the first task and apply that knowledge as the baseline and start learning on top of the baseline for the next task. That is called transfer learning. So you transfer the knowledge from one task to another. That way, the amount of time and effort required in training for the new task can be drastically minimized, drastically reduced. Because since the new task is similar to the old task, we want to borrow the information from the old task and only learn the difference information. And these kind of things are possible in neural networks. And so the Dexter model that we built is a manifestation of transfer learning put to practical use. So this is one thing, and is one last demo I want to give you, which is so the healthcare information that we deal with suffers from one serious constraint, which is called HIPAA compliance, something called HIPAA, HIPAA compliance. And that says that we have to protect information in the data which can identify the patient in some form or the other, right? So that is something we'll have to be very careful about. So what we did is we built a system to filter off the patient information automatically in a given piece of text. So that's what I'm going to show as the last demo. Just give me 1 minute. So this is an EHR, but by the look of it, you can figure out that this is a fictitious EHR. This is fake. Okay, and look at this. This is Rajini Kandu. Somebody who hated Rajini so much has created this chart. So this is a chart, and these are some of the important information, like the name of the patient and date of birth of the patient. And let us see. So I'm going to try if our system can mask this information, mask critical information. So it has masked the name correctly. It has masked the hospital name also correctly into XXX, and the address and date of birth is masked, and date of service is also masked, but the name of the doctor is not masked. So I'm going to try a different name, because the model might have not understood that Rajini could also be a doctor's name. So I'm going to put a different name there. I'm just making it up. See, gone. So this is a known doctor name, probably. Alfred might be known and Nobel might be known. So the model is nicely replacing that with a XXXX. So the idea here is when we do this masking, this is also called reduction. So PHI reduction. So we call it filter. It's again a word play. PHI filter became filter. We call it filter. And this basically strips off information with which you can find the original patient. It will try to strip off as much information as possible. And it also strips off the doctor name in the original chart. So this is another application of sequence classification, another application of NLP, or medical language processing, for removing patient information, personal health information from the medical chart automatically. So the moment we clean up all the PHI information from the chart, then the chart is free to use. We can use this chart for research. So in our lab, all the information that we receive with which we build models, we strip off all the PHIs using models first, and the models are approximately 95% correct. There is a margin of 5% error. So what we do is, in order to address that margin of error, we also use a pair of eyes to check the document. So we manually review it to check if the PHI is all clear, is all perfectly cleaned off. And only after the PHIs are removed, those documents are given to the research community within the company to do experiments with those charts. And we have to be meticulous about it. And the data also resides in the US because whatever data that we receive, the data is coming from US, so it has to stay in US. So we run all our models in the US systems only within that country. Our cloud systems in the US, we will run our models in that system only. So those are some basic things we will have to do to be compliant under the HIPAA guidelines and also information security, right? So I can keep going on and on and on. I hope I triggered a little bit of curiosity amongst all of you to pick up AI for healthcare as a career path. And I wish you people consider that as a good option, because as long as humans are there, healthcare systems are going to exist, and AI for healthcare will be the future, right? It will be the future. And if you are a seasoned practitioner of AI in healthcare, then you will be relevant forever. So that is a very nice proposition I can throw at you. So please consider this as a career path. And by the way, Buddy.ai is hiring. So you can reach out to me if you think you have the capabilities to join our team, the skills and capabilities to join our team. You are most welcome if you have those. Thank you all. Thank you very much.
Yes, sir. Thanks a lot, sir.
Thank you.
It was really informative, sir. And the demos you shown us made us easy to understand. And I guess it will be useful for upcoming techies in medical and AI industry. Thanks a lot, sir. And yeah, it's time for the students' presentation. There are 3 teams: VCEW, KPR, IET, and KCET. Guys, you have 15 minutes for your presentation. At the 12th minute, I'll interrupt you and intimate you. Please complete it by the time. And the first team is VCEW. You can start your presentation, guys.
Janashri, could you please move on to slideshow? Is my voice audible to all?
Yes, yes.
Yeah, good evening all. I'm Yuvetika Sri from VCEW. Sudarshan sir has already clearly explained the process. So let me try to give you a clear-cut definition for a few terms used in this process. So let me first explain EHR. An electronic health record is an electronic record. As already said, it can provide comprehensive health information about the patient, either directly or indirectly, like administrative and billing data or progress data, medical histories of the patient, diagnosis report, medications that the patient have already taken, and lab and test results. So these things could be in the form of electronic health record. And this kind of record help us to improve accuracy and clarity of the medical records, as they can be integrated from multiple sources. Also, there is a reduced duplication of test reports, as human errors are avoided, as well as the reports are faster to start the treatment without any further delay. Next, let us get to know about automatic diagnosis code. Generally, the time taken to diagnose the disease is more than that of treating the disease, and this is the well-known fact. In the automated method of diagnosis system, the software establishes the diagnosis by comparing the patient's symptoms to its database, which is already stored as a ICD, and it does matches the symptoms and disease of the patient, and it checks and gives the immediate report, so that the diagnosis becomes much easier and doctors may start their treatment without waiting for the reports. Thus, automatic diagnosis is a type of computer program in which the code is automatically generated by another program based on certain specifications like symptoms. Now, what ICD actually is? Next slide, please. Yeah. ICD stands for International Classification of Disease. And it defines the universe of disease, disorders, injuries, and other health-related conditions. And it is listed in a comprehensive hierarchical fashion that helps in easy storage, retrieval, and analysis. It also helps in sharing and comparing health information between hospitals, regions, and even countries, as already said, as shown as the demo of that. These ICD codes are found on patients' paperwork, including hospital records, medical chart, visit summaries, and bills. So as I already told, EHR consists these things, which is also included in the ICD. These codes ensure that you get proper treatment and or charged appropriately, leading to the defect of reimbursement. So this not only help the patient as well as doctors. So it is for both. The ICD is maintained by World Health Organization and is distributed in countries across the globe, and thus it is a globally diagnostic tool for classifying disease. And the thing to note is that the ICDs are published in a series of editions like ICD-6, ICD-7, 8A, 9, 10, and 11, out of which we are going to see about ICD-10. Next slide, please. The 10th version of ICD is generally called as ICD-10, and it was endorsed in May 1990 by 43rd World Health Assembly, and it is in use since 2015, and it contains more than 70,000 disease codes. How could we identify the disease codes in sense? It is like specialized one. For example, C for cancer, alphabet L for skin, and I for circulatory system, and V for external cause of morbidity. So such kind of codes are assembled from A to Z alphabets. So with the help of that, we could get what does the disease and symptoms. For example, if it is identified as the symptoms of cancer, it will go on further in like what type of cancer it is. It is either blood cancer or skin cancer or something else like that. So this is the easiest way of finding what the disease is. It is cited in more than 20,000 scientific articles and used by more than 150 countries around the world. And it is also translated into more than 40 languages. And ICD-11 is 5 times bigger than ICD-10, which is endorsed on May 25, 2019. And the news is that it is expected to be in effect officially from Jan 1 to 2022. I would like to thank you all for the opportunity, and let me now hand over the session to Ms. Madhumita.
Okay. I'm Madhumita from VCW. On the continuation of ICD, I would like to get onto the topic procedure coding system. Next slide, please. Yeah, in this slide, we're going to see about the procedure coding system and the 7 characters which are included in the procedure coding system. But before all this, we have to know that what is procedure coding system? It is an international system of medical classification which is used for the procedural codings. And the code which are included in this procedure coding system consists of 7 alphanumeric characters, which includes the 34 alphabetic characters and the integers, and excluding O and I to avoid confusion with 0 and 1. The first character is a section, and the second through the characters mean different things in each section, and there are no decimals in the characters. And let's we get into the character side. Character 1 is a section. It includes medical and surgical, which means in what procedure we are gonna proceed the treatment, like monitoring, imaging, and so on, which is denoted by 0. And character 2 is body system. The system which are present in our body, like nervous system, pancreas, endocrine system, muscular system, and so on. And each of the system is denoted by a specific alphanumeric character. Like if it is endocrine, means it is denoted by H, and if it is nervous system, means it is denoted by 2. And the character 3, it is route operation, which means by which treatment we are going to make the clinical process that includes abortion, delivery, and so on. And it is denoted by 10D, 10A, 10H, and so on like that. And the character 4, it is body part. From the name itself, you can simply know that in which part of the body we're gonna treat. And the character 5, it is approach. That means via which method we will approach the clinical process, like endoscopy, which is denoted by F, artificial opening, which is denoted by 8. And the character 6, it is device, simply which device is used for the treatment. And the character 7 is the qualifier, which is the additional attribute of the procedure if applicable to the treatment. Next slide. Yeah, construction of automatic ICD-10. What is ICD-10 means? It is the 10th version of the clinical modification international classification. Shall we move on to the flowchart of this? We have to extract the uncoded diagnosis description first. What is meant by the uncoded diagnosis descriptions means the information of the patient in a written form. Then it will get into the automatic coding, and it will either a success or a failure in this automatic coding. If it is success means we have to generate the coding success log, and it will get into the audit for coincidence. What is audit means? The independent examination of trial activities and documents to determine. If it is yes means we will complete the coding, but if it is no means we have to go for the manual coding, then only we will complete the coding. But if it is failure in the automatic coding means we have to check whether they correspond to multiple regular expressions. If it is corresponds means we have to generate coding failure log, and we have to check whether it will modify or not. If it is modified means we have to modify the regular expressions, and then again it will get into the automatic coding. But it doesn't modify means again we'll go on to the manual coding, and then we'll complete the coding. But in the previous, if it doesn't corresponds to the multiple regular expression means we have to go for the manual coding, and we'll complete the coding. Next slide, please. This is the construction of upgraded coding system. There are 4 steps involved in this system. They are data pre-processing, diagnosis, terminology parsing, automatic coding, and finally code auditing. What is the data pre-processing means? Actually, the diagnosis descriptions of the modeling data sets are classified based on the diagnosis codes. So when the same description diagnosis correspond to multiple diagnosis codes, or multiple diagnosis codes correspond to one diagnosis code, the one that most coder agree on is used. So according to the ICD-10, each diagnosis code matches a diagnosis description. And next, we go to the diagnosis terminology parsing step. The non-standard diagnosis descriptions representing the same disease recorded by clinicians were transformed to a diagnosis description through the description of model of regular expressions, which means the event of the characters. And next, with the third step is automatic coding, which is the diagnosis description waiting for coding after the clinician fills in the home page are automatically stored in a software called Oracle Database 10G, which denoted by the function regxp_like is used to complete the one-to-many matching between the transformed diagnosis descriptions and an ICD-10 code. If the matching is completely consistent means that code is automatically generated, that means the success log. But it doesn't means the coding failure log is generated. And finally, we'll go to the code auditing. In this, the coders check the coincidence of automatically diagnosis codes one by one through the medical record cataloging system and the process failed codes. And these errors are fed back to the programmers and then modified. Okay, the rest of the slide will be explained by Nivedita. Thank you for the opportunity.
Thank you, Madhumita. Good evening, everyone. I'm Nivedita Karpanan of second year biotech. Now we will move on to the topic runtime processing. First, we'll know what is runtime processing. Runtime processing is nothing but it's a phase of the program which executes and keeps a program running, which includes compile time, load time, installation time, and etc. These are all the process which is involved in the runtime processing. First, it will find high-scoring PCS sections of one-axis prefix. Next, followed by finding high-scoring PCS body systems, which is a two-axis prefix, which is divided into 2 categories, that is generating concepts and generating codes for chosen prefixes. For generating concepts, it includes estimating the concept probability, and then it estimates code probability using concept probabilities as their features. For generating codes, it directly estimates code probability using concept probabilities as features. The main theme for general concepts and general codes is that it estimates code probability using concept probabilities as their main features. Next slide, please.
Excuse me, girls. Your 12 minutes is up. You have only 3 minutes yet.
Okay. Now, advantages. First is fast aggregation of health data. By aggregating the data of numerous similar cases, medical experts can come with more effective treatment methods to accelerate the overall healthcare facility. The data contains an individual patient, includes his or her name, medical history, age, diagnosis, treatment outcome, and family medical history. Second point is no current health situation. With real-time analytics, hospitals can have a 360-degree view of the patient. Using this data, the healthcare industry can deliver proactive care, improving health outcomes, reducing hospital readmissions, and improving all-round efficiency. Third point is wider analysis of human community health. Fourth point is global health assessment. Global health assessment, which is helpful for analyzing or improving the area of study, research, and practice, and achieving equity for all people worldwide. Next slide, please. Last slide, that is limitations. First, it is limited only to a classified disease, and common term descriptions of disease are used. It covers only the most common diseases. It has specific modifier statuses. Thank you everyone for listening to our presentation patiently.
Thank you, Team VCEW. And Team KPRIET can start your presentation now.
KPRIET. Ashwin, your screen is not visible. Can you share your screen? If you have any issues, I will share it for you. KPRIET.
Sir, or else let's have KCET
Yeah, KCET you have.
presentation, sir.
Yeah. KSET, go ahead. KSET, if you have any issues in the presentation, I will project it for you.
I think they have to unmute and talk.
Sorry, ma'am. Sorry, ma'am. I just came, ma'am.
KSET, I am projecting you. Yes, go ahead.
Yes, good morning to the chief. Good morning to the chief guest, and I proudly thank the members of the PALS and the fellow committee members for allowing our college of engineering for allowing to take the project. It's an immense pleasure taking part in this. So the topic we're gonna talk today is about automatic generation of radiology imaging reports. So so we'll see about the introduction. So medical imaging is just a factor used for seeing the internal parts of the body. So it's widely used for clinical practices and diagnosis, and for treating the patients. So what kind of issue is are they facing, and how can it be treated? Our aim in this thing is about report writing. The upcoming generations technologies gave us a good efficiency in the what do you say? The disease detection, like 92% accuracy, 95% accuracy. But we always have a drawback. The main drawback is about the report writing. Even if the report, even if the MRI images and kinds of reports are given to the doctors, only the experienced doctors make them, and inexperienced doctors will face a difficulty in taking them. Even the experienced doctors have some fatal or issues. So our main aim is to reduce the time of the lifespan of the fatal error and finish the process quickly. So report writing can be error prone for unexperienced physicians and time consuming for experienced physicians. So these issues can be eradicated with the help of the studying in automated generation of medical imaging reports. So for this, it's not like the simple one. It has many challenges. So we'll see what and all. Next slide. So digital imaging. So there are two types of digital imaging. Has two types. One is computer radiography, and another was direct digital radiography. So let's talk about computer radiography. It's a digital reproduction of the conventional X-ray film radiography. It's the process of capturing radiographic data from an unconventional X-ray machine and processing the data digitally to produce high-quality radiographic images. And the next one, direct digital radiography. It's more digital in sense. That means accuracy is higher in it. There's no need of cassette. We can remove the imaging hardware that is physically reach the imaging plates. It has digital imaging sensors built into the X-ray table, connected to the computer via a wire cable. It can be used for CCD and TFT directly or indirect with method. So the main difference is as I said before, the usage of cassette is less in DR and CR is more. So currently we are using the direct digital radiography. So as its accuracy and of the portability. Next slide. So radiology. Radiology is the only department which has the connection with the patient, as well as the work is only from 9 to 5. For example, the radiology department, experts speak to the patient and also work for just 9 to 5. The working 9 to 5 is a hassle-free process, and the pay is also a good one. So currently, many of them take radiology as a course after doing MBBS. So what is radiology? Radiology is a branch of medicine using radiation for diagnosis and treatment. So it's an array of image processing. So radiology is divided into two fields: diagnostic and therapeutic. So basically, diagnostic radiology refers to the field of medicine that uses non-invasive imaging scans to diagnose a partial, and the test equipment is used sometimes, involving the doses of radiation and creating a high detail image of the area. So the therapeutic radiology. Basically, the therapeutic radiology is a treatment of the cancer and other diseases with the help of radiation. In other words, it can be also called oncology. It's a branch of medicine focused on diagnosing and treating cancer. Next slide, please. So diagnostic imaging modulation. Imaging modalities means the method in which the images are generated. So the first one, plain X-rays. We know the X-ray scans. Fluoroscopy. Fluoroscopy is the continuous X-ray image, continuous showing of the X-ray images in a serial way. Mammography is the showing of the X-rays to examine about the human breast cancers. Nuclear medicine is about inserting a radioactive tracer generator on the computer to get a nuclear output. Ultrasonic is a high frequency sound wave to view inside the body. For example, treating of seeing the baby images for a pregnant woman. CT scan is a computer tomography X-ray in which the different angles of the image are taken and processed to create a cross section. And MRI, we don't just know magnetic resonance imaging. This radiology is to form the pitch and to take the physical process. Angiography is the radiograph of blood caused out after introduction of radio and substance. The upcoming slide will be screened.
Good evening, everyone. Now we are going to be talking about a specific imaging technique, which is the magnetic resonance imaging. The MRI, it uses a powerful magnetic field, radio waves, and a computer to produce a detailed picture of the body's internal structures that are clearer, more detailed, and more likely in some instances to identify and accurately characterize diseases than any other imaging methods. Particularly, we're going to be talking about the MRI of the head. Currently, MRI is the most sensitive imaging test of the head, particularly in the brain, in routine clinical practice. The MRI imaging of the head is performed for a number of abrupt onset or long-standing symptoms. It can help diagnose conditions such as causes of epilepsy, infections, stroke, and brain tumors. There are some benefits and risks to this procedure. For example, MRI is a non-invasive imaging technique, so it doesn't involve any exposure to radiation. Moreover, the MRI gadolinium contrast material is less likely to cause an allergic reaction than the iodine-based contrast materials used for X-rays and CT scannings. MRI can detect abnormalities that might be obscured by bone with any other imaging methods. So few of the risks include the MRI exam poses almost no risk to the average person when appropriately safety guidelines are followed. However, the strong magnetic field, it may cause implanted medical devices to malfunction or cause distortion of the images. There's a very slight risk of an allergic reaction if contrast material is used. Such reactions are usually mild and controlled by medication. If you have an allergic reaction, the doctor will be available for immediate assistance. If sedation is used, there is a risk of using too much. However, the vital signs will be monitored, so this risk can be minimized. The next slide, please. The next slide, please. Next slide. Now we're going to be talking about an application of this MRI, the MRI brain image classification using probabilistic neural network. The segmentation of brain tumors in magnetic resonance images is a challenging and difficult task because of the variety of the possible shapes, locations, and image intensities. So the objective is to design an automatic support system for classifying the MRI brain images as normal or abnormal using probabilistic neural networks. The classified images are further segmented using fuzzy C-means clustering algorithm, and the tumor part is detected. The procedure includes a multi-level wavelet decomposition, which is by applying a 2D DWT, two-level wavelet decomposition of region of interest is performed, which results in 4 subbands. In 2D wavelet decomposition, the image is represented by 1 approximation and 3 detailed images representing the low and high frequency contents of the image respectively. The GLCM feature extraction, it is the statistical method of examining the textures that considers the spatial relationships of the pixels. The GLCM functions categorize the texture of an image by calculating how often pairs of pixels with specific values in a specific spatial relationship occur in an image. The next is the PNN-RBF training and classification. The probabilistic neural network is a type of radial basis function network which is suitable for pattern classification. The fundamental architecture having 3 layers, an input layer, a pattern layer, and an output layer. The pattern layer constitutes a neural implementation of a Bayes classifier. The next is fuzzy C-means clustering, data clustering technique wherein each data point belongs to a cluster to some degree. Group data points that populate some multidimensional space into a specific number of different clusters. Any point X has a set of coefficients giving the degree of being in the kth cluster WK of X. The performance analysis of PNN classifier is used to measured in terms of specificity, sensitivity, and accuracy percentage and calculated as the same. The next slide, please. Here are some of
Excuse me, guys. Excuse me, guys. Your time is running. 10 minutes is over. Please complete it very soon, okay?
Yeah, sure. Thank you. So here are a few of our output images for classifying MRI brain images, normal and abnormal. As said before, PNN RBF training and classification was used. Then the MRI images segmented using fuzzy C-means clustering and tumor pathology detector. Thank you. Handing over to Purna.
Hello, good evening everyone. Medical imaging is widely used in clinical practice for diagnosis and treatment. Report writing can be error-prone for unexperienced physicians. This task presents several challenges. Firstly, complete report contains multiple heterogeneous forms, including findings and tags. Here is an example of an X-ray report. In this impression section, the radiologist provides a diagnosis. The findings section lists the radiology observation regarding each area of the body examined in the imaging study. The tag section lists the keywords which represents the critical information in the findings. These keywords are identified using medical text indexes. Medical images such as radiology and pathology images are widely used in hospitals for diagnosis and treatment of many diseases, such as pneumonia and pneumothorax. Generating this heterogeneous information is a framework is technically demanding, especially in rural areas. We address this problem by building a multitask framework. This framework treats the prediction of tags as well as the multi-label classification task. And secondly, the next step is to localize the image regions and attach the right description to learn the problems by introducing a co-attention mechanism, which simultaneously attends to images and predicts the tags and explore the synergetic effects of visual as well as the semantic information. And third, the description of imaging reports are usually long, containing multiple lines. Generating such long text is highly non-trivial. Rather than adopting a single layer LSTM, which is less capable of modeling long word sequences, we leverage the composition nature by the report adapt to the hierarchical LSTM. Firstly, a given image is divided into region using a CNN, that is a feature extraction techniques, and then visual features are fed into multi-label classification MLS network to predict the relevant tags and as well as the findings. Then the predicted tags are then word embedding using a LSTM method for features of the image. The visual features and the semantic features are fed into co-attention model to generate the context vector. In this paper, we study how to automatically generate textual reports for medical images with the goal to help medical professionals produce the reports more accurately and efficiently. In this, the information within a unified framework, it is used to generate multiple heterogeneous problems, and it is it also gives a solution to the challenges such as how to localize the abnormal regions and produce accurate description for the problem. How to generate a long text that contain multiple sentences or even paragraph using LSTM method. Thank you for the opportunity.
Thank you, KCET. And KPRIET can now start the presentation.
Imagine with all your mind, believe with all your heart, achieve with all your might. Good evening, everyone. Myself, Priyadarshini, and my team members are from KPR Institute of Engineering and Technology, here to present our idea in the topic Clinical Informatics and Application. What is clinical informatics? Clinical informatics is the study and implementation of information technology in healthcare field and provide proper suggestion to the patient. This informatics maintains and practice the medical record of the individual. The domain of clinical informatics include clinical service to a patient and provides a perfect evaluation with report on patient's detail. It enables the efficient capture, delivery, transmission, and use of data. Through this tool, the healthcare professionals and even patient can access and acknowledge about their medical details. It leads in
Your audio is not clear.
Customization, implementation, and management of health records in an orderly manner. It acts Can you hear me, sir?
Priyadarshini? I request other team members to take it forward. KPRIET team, if she has issues.
Sir, is it audible, sir?
Yes, go ahead.
Sorry for inconvenience, sir. It leads in procurement, customization, implementation, and management of electronic health records in an orderly manner. Clinical informatics also access and refine the clinical decision and support systems. The clinical informatics specialists design and create database system to store the patient's information in a secured manner. The healthcare information includes the electronic health record and clinical decision support systems. In India, the informatics has major importance in clinical trials. Next slide change, ma'am. The American Medical Informatics defines the clinical informatics as the application of informatics and information technology to deliver healthcare services. And Information and Management System Society denotes it as it promotes the understanding, integration, and application of information technology and in healthcare settings. The following session.
Thank you, Priyadarshini. The healthcare treatment will be improved by health informatics. Health informatics is a subfield of medicine that incorporates nursing science technology and the analytic science to standardize the effective manner and the communication of information among nurse, patients, and the healthcare providers. Informatics also elevates the overall effectiveness of the healthcare providers through the number of additional initiatives. The ways in which the clinical informatics is beneficial in healthcare treatment. First, informatics can help prevent harmful treatment and prescription errors. Currently, medication errors are estimated to impact a minimum of 1.5 million patients per year. Unfortunately, the consequence of the misdiagnosing the patient or prescribing the wrong drug or dosage can significantly compromise of the personal health. Incomplete treatment of disease, injury, or behavior are generally evidence of identifiable mistake. The medical community is now prioritizing clinical efforts to reduce the frequency of medical error by incorporating health informatics technology. Second, informatics improve
Lakia, that your audio is not clear.
the acknowledgement of the patient's medical. So now it's clear, sir.
Yes.
So whether it's clear now?
Yes, yes. Go ahead. Go ahead. Quickly finish it.
Informatics improve patient record retrieval. The acknowledgement of the patient's medical report is extremely important to delivery of the quality case that create patient based on their individual record. There is difficulty in diagnosing a patient's medical report. Critical consequence may result. Third, improves accuracy for health insurance administration. To ensure proper compensation for medical treatment, provider, medical care professional must document their work in a specific manner. They must confirm that their administered treatment to patients, then store and record the patient's medical history using the appropriate electronic forms. Then the last one, patient information is safe when stored using the informatics technology. Prior to the Affordable Care Act, many medical records were physically locked away in a secure location, requiring medical professionals to maintain them and protect them from theft. This physical method to record storage does impact patient safety in some ways. Then let me move to the process, the flowchart of the process. Ma'am, next slide. We have come with an idea, which is an application of clinical informatics. It is a chatbot model which runs in a machine learning. The proposed model is a globalized. Let us discuss about the process. A process begins on the interaction of the patient's fundamental information along with their emotions. Emotion analysis play a vital role by dealing with the patient. If the emotion of the patient seems to be unstable, then it is important to make them comfortable. We took certain measures for the comfort of patients. The basic information of the patient's age, height, weight.
Still voice is not clear. Can someone take it from your team member?
It's a question. So whether it's clear.
Yes, yes, go ahead.
We have come with an idea, which is an application of clinical informatics. It is a chatbot model which runs in a machine learning. The proposed model is globalized. Let us discuss about the process. A process begins on the interaction with the patient's fundamental information along with their emotions. Emotion analysis play a vital role while dealing with the patient. If the emotion of the patient seems to be unstable, then it's important to make them comfortable. We took certain measures for the comfort of patients. The basic information of the patients include age, height, weight, and their blood group. After that, the inquiry is about their previous medical record, whether they are prone to any other medication. If they are prone to other medication, our process will be changed. Based on their previous medication, the process is classified into two, and the classification will be explained by
Thank you, Lakia. As Lakia discussed earlier, the flow of the model is divided into two separate mini models. The mini model is categorized by means of the medical issues which the patient has come across. If the patient is already diagnosed for any medical conditions, then the process begins with the feeding of data which the patient has. Informatics of the patient is compared with the
Within 1 minute, you have to complete your
predefined data
presentation.
on which the model is trained to test. By means of NLP and Peaks algorithm, we have developed the keywords and retrieved from the patient's report and compared to the test models. Before generating the report, the current informatics of the patient is fed by
I think he has some connectivity issue.
Hello, sir. Can you hear me, sir?
Yes, you have only 1 minute. Please finish it quickly.
Yes, sir. Yes, sir.
In order to increase the accuracy of the model, large amount of data we have used. Next slide, please. If the patient haven't reported for any medical issues before, the process begins with a questionnaire. The questionnaire consists of interactive questions either by voice or text. By the data clustered during the questionnaire, and comparison process takes place using Peake's algorithm. A comparison of data occurs between clinical informatics, which the model is trained on clustered data. The data obtained is converted into a report after checking the emotional state of the patient. I hand over the session to Ashwin.
Thank you, Karthik. We have processed our idea by the classification algorithm for the early or self-diagnosis of the disease. As I explained earlier, the data of symptoms is collected from patient and it's made compared with database available with us. The backend process of our idea is the disease prediction table, where the disease are classified based on their major and minor symptoms on a looping process. Each symptom is compared with each of the disease and they are recorded in a form of confusion matrix, where if it is true, it is marked as 1 and if false, it is marked as 0. This is repeated for all the patient's symptoms. Here we just expressed our idea with 5 diseases and 5 symptoms. Finally, the overall confusion matrix is created and from which the analysis is done by taking the peak value from n symptoms. From the analysis, the disease can be predicted with an accuracy of 90%, which is provided as report to the doctor and then to patient. With this analysis of the patient, accuracy can be increased by converting the confusion matrix to K-means algorithm. K-means algorithm is in which n observations are mapped into K clusters in which each observation belongs to the cluster with the nearest mean. And now we are thinking on the K-means algorithm to improve the accuracy. Now the session will be continued by Ms. Fatima.
Your time is up.
Thank you, KPR IET. I mean,
thank you for the opportunity.
Yeah, not a problem. The connectivity issues.
You can stop sharing your screen.
So Santhiappan, any comments, sir, on the 3 presentations that we've had? I think they're highly, deeply technical in nature.
Okay, see, my comment would be that these students have done a good job doing fundamental research on the problem statement. So I'm happy about the research that they have done. Okay, the expectation was not to find a solution to it. The expectation is just to analyze the problem statement and look at the length and breadth of the problem. And I think the students have done a good job. So I appreciate all of them.
Good. We also had the students to come up with any questions they might like to ask you as a specialist. I think they have put up something there.
Yes, it is recorded in the registration form. So I have taken the questions.
Okay. So, do I get to see that? I mean, I don't see
it. Yeah, it's there on the screen.
Yeah, it is there on the screen.
So these are the questions. Okay.
Yeah.
Okay.
Can we able to predict the evaluation and revolution of pathogens with the help of medical language processing?
Robin.
Okay, I don't know if the question itself is well understood. See, the pathogens, why would the pathogens be represented as language? I mean, as text? So I don't really understand if the question was well thought of. See, the pathogens, I think, I don't know how the information is stored. We don't know that yet. I mean, the thing is, it could be images, it could be their DNA signatures, or it could be the protein signatures. See, their data, the representation is very different. They are not really written in natural text. Right? Medical language processing is aimed at addressing information represented in natural language. Of course, the verbiage is medical, but the language itself is plain English, right? So if pathogens are represented in English language or any natural language, yes, then MLP can be applied. But as far as I understand, the representation or the way we view pathogens, I'm not sure if it is viewed as text. I think they are viewed as images or protein signatures.
Okay.
So the second question is, how could we combine technology with codes for better usage and availability? Again, I'm not really sure if I understood the question. What do we mean by combining technology with codes? What is the meaning of that? Whoever asked, can they explain that, please?
Because it is recorded in the registration.
Okay.
So,
okay, I'll move on to the next question.
Yeah, next question. Yeah.
How can we deploy ML model into a self-created application using MIT App Inventor? Wow, that's kind of deep and heavy. What do we mean by self-created app? Oh, the application that this individual has created. Okay. Sure. See, there are several ways of deploying machine learning models. The easiest deployment is by invoking the appropriate APIs into your piece of code so that you can use them. So usually there are these libraries. The most popular one is called the sklearn, the scikit-learn library, which is a part of the Python libraries. And one can create models using sklearn library, and the models that are created can be invoked in your application by making appropriate API calls. So that way you can put the models to use in real life. There are several other ways of deploying machine learning models. Usually the machine learning systems or AI systems are implemented as pipelines. And machine learning models are deployed in different blocks of the pipeline so that new models can be rolled out and old models can be revisioned. See, in a system which involves different versions of the model, then it becomes a headache on which model gave what result. So it's a big headache. So there are machine learning deployment solutions which are available both in open source world and also in proprietary commercial world for deploying models in large systems. So the simplest way of doing it is by invoking the appropriate model APIs into your piece of code. And how easier can be the medical coding? How easier can be the medical coding be cut down in relevant, easier understanding? Can somebody rephrase this for me, please?
This is the limitation we have with online
bots.
online sessions.
Yeah, bots. Okay. So I'm going to interpret it in my own style.
Okay.
How easier can be medical coding to cut down to easier understanding? Okay, the cut down part is what I'm getting completely lost. Okay, if I can understand this as how easier is automatic medical coding, if I understand the question that way, it is not an easy problem. I would say Buddy.ai is the first to solve this problem for some of the specialties in medical coding. For example, We solved the problem for the emergency room specialty. We are the first in the world. For radiology, our automation solution is working in real life with more than 95% performance. Again, we are the first in the world. And we are developing surgery automation. So medical charts created out of surgery visits. And when we deploy it in production, we will be the first to deploy it. So it is not an easy problem. And we have taken about 7.5 years now to get to here. So there's so much of effort, so much of hard work which has gone into build the solution. So it is not easy. And medical coding as a profession, again, is not that easy, but there are training institutes which provide that skill for a fee. So I've seen a lot of engineers getting into medical coding profession, but let me warn you here, medical coding as a profession will die in another 5 to 10 years. After 5 years or so, there will not be any human medical coders, and I'm sure machines will be medical coding 95 to 98% of the times. So I would say don't take that as a profession, but if you learn medical coding as an additional skill, yes, you are relevant to work in an AI company that has products for medical coding. There will be a lot of AI companies which will have the solution because the market is huge, and there are very few players in this space. So new companies will definitely come up, and they will be very interested in hiring an engineer who understands medical coding. So that would be an awesome thing to do. But medical coding as a full-time profession, don't think about it if you want to think about it now. That is all I could interpret from that question.
Fine.
Okay, fine. Thank you.
So thank you, Dr. Sudarshan.
Before calling Mr. Arun Dev, for the participants, so I will post the online quiz link and feedback link. So please submit the online quiz as well as feedback link. So feedback is very important for us. Thank you. I request Mr. Arun Dev to give a vote of thanks.
Yeah. Okay, so that was quite a heavy session between 4:30 and 6:30. But I think Mr. Sudarshan had warned us about this well in advance. So I'd like to thank Dr. Malati for the introduction and Dr. Malati from BCW for her introduction. Thank you for your support and kind words on the PALS initiative to try and get students more oriented to what industry requires. Dr. Sudarshan, your session was deep in technology, but at the same time, I think it also brought out very clearly the very different challenges that you have faced the last 7.5, 8 years, trying to make it amenable to something in a very competitive market like in the US. So how to incorporate AI in the medical report. It is not as simple as it sounds. It is something very deep, and there's a whole lot of challenges that have been overcome in trying to come to the stage that you are in. It is also very good of you to have explained a lot of aspects on auto coding, as well as a lot of the things on the industry standards like your SNO, MED, etc. So that gives students a necessity to look at various aspects when they dive deep into this system. I'd also like to congratulate the 3 teams. As Dr. Sudarshan had mentioned, I think it was a very good effort trying to understand and trying to come up with presentations on the 3 different topics that he has suggested. And it was, I mean, we did have some technical issues, but otherwise, in terms of content, I think they're all very well made. So with that, I'd like to thank everyone for attending this session. I hope it was very useful. As he said in his concluding remarks, I hope he has created the curiosity to pursue AI for healthcare, which will be very relevant going forward. So thank you very much, and thank you, Dr. Sudarshan, once again.
Thank you. Thank you. Thanks for the
Thank you,
opportunity.
sir. Thank you,
Mr. Sudarshan.
We look forward to having you more.
Sure. Anytime. Thank you.
Thank you. And remember, he had an open invitation to join if you're interested in this area.
Yeah, absolutely.
Thank you. Yeah.
Our doors are wide open.
Yeah.
Thank you, sir.
Okay.
Yes.
Thank you.
Good night.
Thank you. Thank you, sir.